Hi everyone, hope you're well. I'd like to welcome you to the final part of our winter webinar series. My name is Alicia Bothwell and I'm one of the marketing executives based in Northern Ireland for Randox Diagnostics. Our topic of discussion today, presented by Dr. Sibanda, is reducing the role played by dairy and dairy products in antimicrobial resistance, a question of method performance. Randox offer the full package for milk testing. We offer antibiotic and pesticide testing on our evidence investigator. It's great that we can come together like this over shared interests in these uncertain times. Just as a side note, can I please ask that you refrain from using the raise your hand function during the presentation, and any questions can be asked at the end of the webinar. Without further ado, I'd like to introduce my colleague, Dr. Sibanda. Dr. Sibanda holds a PhD in Pharmaceutical Science, focused on the development of accelerated methods for mycotoxin detection, as well as an MBA in International Business Management. Dr. Sibanda has extensive experience providing solutions to government residue monitoring programs and testing laboratories in Africa, Europe, Latin and North America. Without further ado, pass over to you, Liberty. Sorry, just technical issues. Hi, Liberty.
Hey, Alicia. Hi. Thank you.
With you here.
Good morning, everyone. Maybe good afternoon to some. Thank you very much for joining us today. Today, I'll be talking to you about reducing the role played by dairy and dairy products in antimicrobial resistance. So is it a question of method performance? So these are some of the things that we'll be looking at today. We've seen a number of headlines, things like superbugs soon to kill millions of us each year. And sometimes, we look at these and then we think, oh my goodness, is this for real? The BBC in 2014 spoke about drug-resistant infections will kill an extra 10 million a year worldwide. In 2012 as well, the US Public Health Service also had headlines like the potential threat to human health is significant as pathogenic resistant organisms propagated in these livestock are poised to enter the food supply and could be widely disseminated in food products. And recently, just a couple of months ago, there was, the Food Navigator online food journal spoke about concern over next pandemic. We are in a pandemic at the moment, but they're talking about the next pandemic, spotlighting on the antibiotic use in meat, so this is more to do with antibiotic resistance. So testing will help restore trust. That's what they say. Okay. So normally, antibiotic use in livestock, especially in dairy, is to do with specific disease treatment. So here I would just like to give an example of mastitis treatment. With mastitis, there are two forms of, the contamination or the incidence of mastitis. So one of it is contagious, and this is through Streptococcus galactiae, and then the other one is Staphylococcus aureus or Mycoplasma. The other ones, cattle just pick up, these diseases from the environment, especially from the Streptococcus species, or, the coliforms or coagulous negative Staphylococcus. as well as other bacteria. However, some farmers really will use antibiotics as a prophylactic kind of thing, just to prevent the occurrence of diseases in the animals. And maybe sometimes, because it's very difficult to identify mastitis causing bacteria, therefore let's just eliminate the entire thing or prevent it, by just feeding antibiotics to our cattle. But we know that gram-positive bacteria, for example, the streptococci and the staphylococci, these ones require antibiotics, that's for sure. But gram-negative bacteria like the E. coli, and others, normally when you have infection from these, they'll just work themselves up 90% of the time. So it might not really need antibiotic intervention. In most cases, intramammary labeled antibiotics are not suitable for a lot of clinical cases of mastitis anyway, but you find farmers using them. But there are specific cases like for E. coli. If you treat E. coli with cephalosporins, these may actually elicit or cause the occurrence of beta-lactamase activity. But we know that cephalosporins are also used in human medicine. So the use of antibiotics in animals is rife worldwide, but there are some jurisdictions where there is higher use of antibiotics. And The Guardian here, just this week, we're talking about antibiotic data from around the world, highlighting places like the US, Australia, New Zealand, Canada, that they're using more than 5 times what actually like maybe some countries in Europe are using it. Yeah, they actually are giving the example of UK. So 70% of antibiotics are used in animals, for animal production, and 30% of those are also used, are shared with human beings. So if we do not manage antibiotic usage in animals, so antibiotic resistance will end up occurring, and with zoonosis also being a very, very important threat, we'll have infections moving from animals to humans and moving together with antibiotic resistance. So, and when we try then to use those antibiotics that are used in animals, in humans, and yet the pathogens now are resistant, then that is the next pandemic. So, but how does antibiotic resistance really work? So, like I've pointed out, prophylactic use actually is one of those problems. Growth promotion, increased feed efficiency. So those are the reasons given by farmers, for use of antibiotics. But then these result in multi-drug resistance in disease pathogens, and we find genes against antibiotics, now becoming present in both non-pathogenic and pathogenic bacteria. So the rise and increase in antibiotic resistance really is a global threat. The US Center for Disease Control says more than 2.8 million antibiotic resistant infections, resulting in close to 12,800 fatalities annually in the US. That's the reality in the US. But how does it occur? You have a resistant, bacteria. So the resistant genes can be found either on a plasmid, like this in this specific example, or you can find them on the chromosome. So they can either be plasmid-based or chromosomal. So when a resistant bacteria comes into close contact with a non-resistant one, they start to conjugate, and this is usually through what you call a pilus, and so it's kind of a tube connecting the two bacteria, and the plasmid will replicate, and the copy of the plasmid then is transferred to the non-resistant bacteria, which then is transformed to a resistant strain. There are two forms of resistance. So one will be, the ability to produce an enzyme that breaks down the antibiotic. So, I've shown you, I've just spoken about the beta-lactamase activity in E. coli. And then we have also possibility of, the formation of active pumps. So the active pumps, there are different types of active pumps depending on which specific antibiotic that the bacteria is reacting to. So we have active pumps here permeating the cell wall and the cell membrane of the bacteria. So what they do is they flush out the antibiotic. Once the antibiotic enters the cytoplasm of the bacteria, that is flushed out. Okay, so it's the same as in humans or animals. When you eat poison and then you vomit, so you're actually trying to get rid of that poison from your system. So that is what one of the activities or features or characteristics of antibiotic resistance in bacteria. So some of the examples of antibiotic resistance really are found, found in milk. So especially the Staphylococcus, especially Staphylococcus aureus and the Streptococci, they exhibit a lot of antibiotic resistance in milk. So they've been found to have all these antibiotic resistant genes, and you can see that some genes are located on the chromosome and some are on the plasmid. And this beta-lactamase gene for Staphylococcus here is actually located on the plasmid. Very easy to share, between one bacteria and the other. So this is why actually many jurisdictions have come up with regulations, because the exposure to residues of antibiotics has to be controlled. So I'm just going to give an example here of the European regulation regarding antibiotic residues in milk. So businesses or dairies are required, to ensure that antibiotic milk, positive milk, is not placed on the market, and also they must inform the authorities, whenever they find, antibiotics in their milk. So this should be reported. In the on-label antibiotic use, you must make sure that you respect the withdrawal periods. And in the cases of off-label use, you must wait a further 7 days, to the prescribed withdrawal period on the label. So you add 7 days because this specific use is not mentioned on that label. So you have to wait a further 7 days and continue to test your milk until it is clean. So Council Directive 96 of 1996, 23 of the European Commission requires processors to have checks in place. So this is auto-control. It includes HACCP, but at the same time, it also, within the HACCP, you're also looking at the residue contamination. So you have to make sure that your milk does not have residues exceeding, the maximum permissible limits, and it also does not contain prohibited substances. So there are various regulations around the world, but I'm just going to highlight three. You know, the one that is known or used all over the world is the Codex. But throughout this presentation, you will notice that Codex has less regulations. So this is a big problem, really, because with a few regulations that are in place, that are actually suggested by Codex, you know, countries only have can choose whether to adhere to these regulations, whether they want or not is up to them. The US also has regulations. They are more than those of Codex, of course, but the region with the most regulations is the EU. So the EU has a lot of regulations. So you can see each group or types of antibiotics, the EU covers all of them. You know, the US does a bit, and only a few for Codex. So depending on the region where you are, you know, farmers and veterinarians can actually work together to use antibiotics that are not being regulated. And this is a big problem when it comes to the issue and the threat of antimicrobial resistance. Okay, even for macrolides, you can see the EU is covering everything. And then there's quite a lot of gaps for Codex and the US. Is the same for quinolones, nothing for US and Codex, tetracyclines, everything is covered here for the EU. Anthelmintics, the same story goes again. So across the board, you'll see that you have everything covered by the EU. And then we are having a lot of gaps. So in these jurisdictions where there are a lot of gaps for antibiotic regulation, for me, that is where I see the red flags with respect to potential for the increase of antibiotic resistance. Now, there are tests that I then used to check for these antibiotic residues so that, you know, consumers are not exposed to, you know, low levels of antibiotics in the milk and milk products, which may lead to antibiotic resistance in our bacterial flora or in the products themselves, you know, and then we may consume them and pick up bacteria that is already antibiotic resistant. So there are many platforms and different techniques that I use. So the simplest really is the dipstick, where you can actually detect, you know, you can check whether, you know, there is antibiotic or not. So this one can test one antibiotic, but you can test maybe up to 3 antibiotics maximum on these systems. So these systems are simple, very easy and fast. And then, of course, the simplicity and rapidity also comes with drawbacks. So sensitivity, accuracy, and reproducibility is also a problem over here. So, and then the other format is the bacterial inhibition. So here, they use, or this test actually use Bacillus stereothermophilus to detect antibiotics in the milk. So I've seen this actually in 2 formats. One is called the on-farm test. You know, you have 2 tubes here, and the one tube, the one with the blue here, it means that this sample is positive. If it turns yellow after incubation, it means that the test is negative. So they also have a plate format here just below. This is for laboratory, okay? So this one can take more samples. You can do up to maybe 96 samples if it's a full plate. So there is that flexibility on this test, but it takes 3 hours, you know, to test. So this test actually only tells you whether there's an antibiotic or not. And only tells you for those antibiotics it can detect, because there are quite a number of antibiotics this test cannot detect. Like I said, there is this Bacillus stereothermophilus in this media, so this is why it looks navy blue. So if the sample, if you put a milk sample in here and contains antibiotics, the bacteria will not grow because it is sensitive to that bacteria, to that antibiotic. However, if the sample does not contain an antibiotic, the bacteria will grow and produce an acid, and that acid will change this indicator to yellow. Now, but this bacteria here is only sensitive to a certain number of antibiotics, not to all antibiotics. So for example, it's sensitive to 3 tetracyclines, but then it misses chlortetracycline. It's not sensitive enough. So it can detect maybe up to 20% of the sulfonamides. It misses 80% of them. Aminoglycosides and macrolides, it misses over 60% of aminoglycosides and macrolides. It cannot detect chloramphenicol. It cannot detect quinolones. So if you get a negative result, yellow color over here, and then you give, you pass that milk batch, to be placed on the market, remember that it misses a lot of antibiotics. This milk glass here can still be contaminated with a lot of antibiotics. So, but which other method then can you use? You can use HPLC, for example, but this system only tests one group at a time, or one antibiotic at a time. So for example, these 4 peaks over here you see on the screen, these could be the 4 tetracyclines, for example. But then to come up with this result, you need to run this for 2 days, sample preparation, in cleanup, and then you run the standards, the calibration, and then you run the samples. And turnaround time, usually when you send this to a lab, is at least a week. Okay, so it is expensive to put it up, expensive to run. This can cost you $100 dollars per sample per analyte. So it's quite, if you had to test 10 different analytes, 15 different analytes, so you can multiply that and see how much it costs you. On the other hand, you also have the LCMS, and this one can actually do more. You can multiplex here and do a lot of antibiotics. But the issue is it's very expensive to, initial investment, and you need well-trained personnel, and you require costly sample cleanup, and then you also need standards to run it, and you need expensive internal standards as well, and results. Also, you have to wait about a week. So how dairies and the dairy industry working with this? I know an example in mainland Europe where they use a bacterial inhibition inhibition test at the beginning. So if that one comes negatives, then they say it's a pass. But I've shown you before how much you would have missed. Even if it's a pass, you'd have missed a lot of antibiotics, and this takes 3 hours. And but if it's positive, so they do a beta star, a beta lactam test. And if it's positive, then whichever farmer produced it, they are penalized. However, if this one is negative, so they apply beta lactamase. So remember, beta lactamase is an enzyme that destroys beta lactams. So, and then they run the bacterial inhibition test again. So if it now turns out to be negative because we've eliminated the beta lactams, then the farmer is penalized. So again, these are all taking a lot of hours to do, all these steps. However, if this result here for the bacterial inhibition test, if it is positive, then they start to do the dipsticks, which then can identify the individual groups, whether the tetracyclines or the aminoglycosides, the macrolides, the quinolones. So this will take you for one sample just to do one analysis, effectively, it will take you more than a day. Okay, so this is where actually Randox Diagnostics comes in with our biochip array technology. So we are not just coming from Norway. I mean, we've been working for over quite a number of years with big multinationals in milk testing, and a lot of really reputable food establishments have been using our system for a while. And this system is based on biochip array technology, and it comes in the format of a biochip carrier, and each biochip carrier here has 9 biochips, and on each biochip, for one biochip is for one sample, and it can do a lot of analytes just in one go. Okay, so on a biochip carrier, you can do 9 samples. Okay, so you can do quite a lot. For milk, for example, it goes up to, you can generate, for the 9 samples, you can generate 387 results. So the biochip actually comes with 4 reference spots. So the green ones, I hope you can see them, over here. So this is a quality control feature on the biochips, that really gives or maintains the fidelity of the test. So we have qualitative tests, we have quantitative tests, and our flagship qualitative test is what we call the Infiniplex, simply because it can test everything that is regulated to infinity. Okay, so we have on this specific one, on the Infiniplex, there is no sample preparation required. So we throw out the cost for sample prep. Okay, so this can be run on the evidence multistat right over here. This is an automated system. It has a touch screen. You can actually direct everything on this computer here. And it's a touch screen computer. And it's an automated system. So, but it tests one sample at a time. Very suitable, for dairy environments. In that one sample, it only takes you 20 minutes to get your results, and you have results for up to 130 samples. Okay, so in a day's work, a day, you can actually test 24 samples on this system. So this is a tabletop or benchtop, depending on where you want to place it. The Infiniplex can also be run on the Evidence Investigator, okay? So the Evidence Investigator is a semi-automated platform, testing up to 48 samples or more, actually, of samples, and also up to 130 compounds simultaneously. And the results, you get them in 2 hours. So can you compare this to the 3 hours or the HPLC or LCMS I've just shown you before? So this actually allows you to have a global view and global control of all the residues that that might be in your milk. So it does not leave anything to question, okay? So you can do a minimum of 2 samples on this system, but you can do up to, you can run up to 96 samples, together, within 2 to 2.5 hours. So the good thing about the Infiniplex is that, we can do all this, okay? And in everything that is regulated by the everything that is regulated by the EU. And let's say yeah. So, but the problem here we have, the reason why we are detecting only 98% is because monensin needs sample preparation. Okay, Monensin needs sample preparation, so that is why we did not include it here. Okay, so that's why we are only doing 98%. But the power of the Infiniplex is such that, you know, we can actually tell you what is contained in the formulation you used to treat your animals. You know, there is a case once in Europe, it is actually here in the UK, you know, where one farmer was found by the authorities and they found antibiotics in his milk. And he was actually, he refuted, you know, he proclaimed innocence and everything. But then they searched his farm and they found, you know, a bottle, you know, that has been used, you know, for treatment on his farm. So the results of the Infiniplex can actually tell you, in that case, they told you know, the government authorities that there was penicillin G, and there was novobiocin, there was neomycin, and also streptomycin. And actually, this is a formulation for tetra delta, okay? So when he was confronted with that evidence, so there was nothing else because this tetra delta was found on his farm. And again, this is the proper formulation, and it can be actually shown on the Infiniplex results. So that is what Infiniplex can do. So can you imagine that Infiniplex can detect all these in one run, okay, without sample preparation, okay, either on the automated system or on the evidence investigator, the laboratory benchtop. Regarding quantitative results, we actually, like, if you run the Infiniplex, if you want to do a further analysis of what has come out positive, then you can use antibiotic specific or group specific kits, like, for example, the sulfonamides. So this is AOAC certified test. So you can actually use this one to quantify each sulfonamide in the sample. If the sample came out, you know, showing that, you know, sulfonamides are present, because that test, the Infiniplex, can tell you which antibiotic is in there. It does not tell you it's positive or negative. It just tells you that this antibiotic is there, this one is there, this one is not there. So you don't have to worry. So, but for the ones that are there, if you want to check now and do a quantitative analysis, you can use the evidence investigator or these kits then. So within each kit, it generates a specific calibration curve for each analyte, okay? So if you use the beta-lactam array, so here you can detect, you know, 19 compounds, antimicrobial array1, that is the sulfonamides. You can detect 15 sulfonamides. So the antimicrobial array2, here you can detect up to 35. You can do the anthelmintics array as well, mycotoxin array if you want. And the Infiniplex 2, really this is the additional anthelmintics array, almost 48 compounds can be detected here. So in addition, really, you know, because we have a comprehensive approach to residue testing in milk, so we also have pesticide detection on this system. So we can do up to 17 pesticides in milk. And you know, the you know, WHO and everybody else are talking about One Health, you know, because we have these zoonotic diseases, you know, coming from animals to humans, and then we have this issue of antimicrobial resistance. So now there is what they're not talking about, what they call the One Health. So Randox is coming in, you know, to actually also assist in this One Health, you know, approach. So we have, you know, the bovine pathogen array where you can detect, you know, bovine viral diarrhea, Leptospira, IBR, which is infectious bovine rhinotracheatis, and then you can also detect tuberculosis, salmonella, fasciola, and neospora on this chip, simultaneously. Okay, so you can do a lot on this system, so you don't need to be running around looking for different types of facilities or platforms, to do your detection. Everything, you can do it on one thing. And in addition, you can actually monitor the antibiotic resistant genes, say, in your dairy cows, in the milk. Are we having anything, really on our farms with respect to resistance? Are we having a propagation of resistant genes on our farm, in our flock? And this you can actually do again on the same system. On the biochip, you can detect all these antibiotic resistant genes. Application areas, really. So the multistat can be used, by the food, milk, dairy processors, and they don't need to send, samples to the lab. So you can actually do everything within, 20 minutes. What is in there totally. Don't need to run many tests, just one test, and you have very sensitive test that gives you very good results. And if your results come out negative, you can quickly package your products. You release your batch, quickly. But if you have any positives, then you can send them to the lab, and for confirmation, I can do in other confirmatory tests. But at least this allows you to have a very a global view in terms of quality of your production, and can allow you to release your products quickly. For those that are in the lab, and you may want to increase, your testing throughput, then you can use the evidence investigator pretty quick, and so you get quantitative, very accurate results. So, but if you want to do any further confirmation of positive samples, then you can then begin your sample cleanup, adequate enough, to be loaded onto your LCMS. In this case, you don't want to overload your system, because then your source gets dirty quick, and you need to get maintenance on the rods, because your sensitivities have gone down. So you want to mitigate that. So to mitigate that, this is a very good assistant to the LCMS. We've done some studies elsewhere, but I'll just show you one where we did over 300 samples of farm, tinker, and final product samples in comparison with LCMS. So we did this with ILVO. This is a Belgian reference laboratory. And you can see here that for the ones that were found by Infiniplex to be positive, they were confirmed by LCMS to be positive. But the ones that we found out to be positive and there's no result from LCMS is because the sample, you can read here at the bottom, there was insufficient sample to run the LCMS. So you can see that the biochip technology is very, very effective and very comparable to LCMS. And again, you can see this is one of the posters we had at one of the international symposia. So we've done, milk samples from across the world, really, and of those, we found 10% of them to be contaminated. And for those that are the 10% that were contaminated, 40% of them were contaminated with beta-lactams. So, but a lot of people are using tests, okay, to test and screen. You have 10% that are on the market, farm or tinker or finished product, in the markets, 10% of them are still contaminated. Why? You know, this has to do with the sensitivity and ability of those tests really to pick up these tests. But this is what we are very good at doing on the biochip array technology. And 16% of that 10%, 16% of them were actually banned unauthorized substances. So how can it be that you find, you know, Tinker milk, you find products on the market that have unauthorized substances, and yet people continue to test? So just to summarize, you know, the biochip array technology really, you know, gives you, you know, a number of benefits. You know, first of all, simple sample prep. So you throw away the cost of sample preparation, you know, and you are able to do many methods in one run. You know, on one sample, many methods, and you're done within a very short space of time. And again, the testing is based on or geared to regulations, especially EU regulations. So we try by all means to be below the EU regulations. So because our tests are quantitative, so you're able to actually see where the concentration of a sample falls with respect to you know, the regulation. And we have an extensive menu. So no one is left, you know, wondering as to whether, you know, they'll be able to meet the regulations or not, or are they testing enough. So we cover everything that is regulated, I would say, perhaps throughout the world, because the EU tests, I mean, regulates more than everybody else. So, so I'd like to thank you for your attention today. And so should you have any questions at all, so you can send your questions to info@randoxdiagnostics.com or myself. But please, should you have any questions at all, please do not hesitate to get in touch. So now I'm going to give you back to my colleague, Alicia. Hi, Alicia, I think you have control now.
Hi, yeah, I think I do. I don't think my screen is coming up. Okay, so thanks everybody. Thank you, Liberty. That was very informative. We're just going to have a look at any questions that have been asked. So the first question, Liberty, can milk be put directly onto the biochip, or is there any sample preparation needed prior to this?
So thank you. So we have a very simple system. So on the Infiniplex, which allows you to test a lot, almost everything that is regulated, there is no sample preparation. So you can take your fresh milk just like that, and you pipette it onto the biochip, and off you go. So for that one, there is no milk. There's no sample preparation required. So, but if you find any positives, then maybe then you can change to another test, you know, to then do a quantification. So there you will have a very simple, almost one-step kind of milk clarification test, I mean, sample prep. And with that one, then you can do quantification. So, but it's a very simple sample prep step.
That's great, thanks Liberty. Just a second question here. What other dairy products can you test on the Infiniplex apart from milk? What about milk formula?
So we've done some studies, I think especially with Nestle. We've done different types of matrices, really types of baby foods. So, so there's quite a range of matrices that you can test, you know, on our biochip, apart from milk itself. Things like cheese, I think, will be coming in due course, but other matrices that are simpler, powdered milk, milk formula, those things can be tested, of course.
That's great. Thanks very much. I think that's all that we have time for today. So again, thanks everybody for joining. That was really great. If you'd like to contact us, like Liberty said, you can do so at info@Randox Diagnostics. If you want to rewatch the webinar or share it with any of your colleagues, we'll be uploading this to our social, so you can access it there. Any questions that we didn't have time to answer or any that you think of later on, just send us a quick email at info@Randox Diagnostics and we can get back to you then. Thanks very much, everybody.